Right. So this is a course objective. It's, as I told you, it's an optimization techniques, and we'll be using the mathematics and computational skills, and also we'll be we'll be interested in teaching you the network methods, the inventory and queuing. So these things, not only for this course, this will be useful for your lifetime also. So how do you schedule your network? How do you schedule your activities? And how do you plan your inventory? So all those things has real meaning, like real time importance. So you can, for example, if you conduct an event, so you can even do deploy all the skills you learned in this course. That's why this course is kind of a pretty straightforward course. And say somebody who turns out be a design engineer in future, so they need to optimize the components. So all those things like decisions and replacement models. Say if you're in charge of a plant, then you should really have a methodology to do a maintenance of the equipment or replacement of the equipment. So all those decisions will be based on some mathematical concepts, and that will be taught in this course. So that's basically this course objective. And let's skip the course outcome as of now. And this module have, I mean this course have got 7 modules, and 8th module being a guest lecture. So we'll generally invite people from working in industry who have got a rich experience in managing projects or services. So that will be our 8th module, the contemporary thing. But as a theory, we have got module number 1 to 7. In the initial module, it's called linear programming problem. In fact, this is one of the favorite, my favorite concepts in OR. In fact, this was, developed during the Second World War. They use this for, strategy in the warfare and other related stuffs. This is basically used in military. Later it gets used in other non-military civilian sectors as well, or industrial and civilian sectors. And this is a very important thing. We'll talk about that in the next lecture in detail, but linear programming is a very important concept in OR. And module number 2 is a special type of linear programming. So do not get carried away. It's a different problem, but it's a special case of linear programming, when we will look into the transportation problems. We'll see how we can transport a good from one place to another, or you can, if you want to avail a service, you look into the nearest thing. So in fact, this also have got huge implications during World War II. Transportation of the equipments, the missionaries, then troops and something like that. So this plays a huge role. And in fact, we are in the modern era, where you can, if you want to book a taxi, you go to that particular app and you search for the nearest the taxi available, right? So that's basically a transportation problem. It looks into shortest method. Or sometimes if you have seen the map, the app has a map, sometimes a driver will take a short route, so that as and when he takes the short route, the direction changes, and finally it gives you, the driver reaches you more ahead of the scheduled time or something like that. So that's basically is all about a transportation problem. Or if you want to order a food, you can calculate the nearest restaurant which you like, and that's all is a transportation problem. So something related to that, right? So a good decision happens if you have a firm objective, as well as the constraints are minimum. So that's how you, or you have the ability to revoke the constraints. So that we will be doing it a little bit so something like that. So, and module number 3 is also a special case of linear programming problem, but it's not the entire thing, but only the assignment problems. Assignment problems are special case of linear programming problems, when which this is more of a mechanical engineering perspective. Like it's all about how do you allocate jobs to machines. Say number of jobs to only two machines, and number of jobs to 3 machines, and number of jobs to m machines, which is the machines are huge or something like that. And in all the 3 methods, the linear programming problem and transportation problem and assignment problems, we'll be looking at some portion of it in a graphical form. So not purely a mathematical calculation, but some form will be looking into the calculation perspective, or in the graphical perspective, or sometimes both. That's a combination of both we will do. So something like that. So if you're really interested in graphical method, you can get some graph sheets or something like that. But if you can make up 1 centimeter, axis, 1 centimeter x-axis and 1 centimeter y-axis, you can make up a graph sheet in your plain sheet of paper itself. So these graphs are not very complex like in the case of a calculus or something. And as the name suggests, it's a linear programming, and it does not have any it's a non-linear curve or something like that. So you can make use of the straight lines, and you can find the intercepts pretty easily. And as I told you, these are very close to one another. And one of the important problems in linear programming, or one of the important methodology when you can solve linear programming problems, is a simplex method developed by Danzig, and he got Nobel Prize for this. So this method is a very important method. And then there's another associated method called big M method. It's actually big M method and two-phase method, and something called duality. We'll talk about that a little later. And this is what and very important thing in model number 1. In fact, later in 1950s, late 1950s, Indian mathematician called Narendra Karmarkar. So he has developed a method called Karmarkar's algorithm. And even now, till date, Karmarkar's algorithm is considered to be one of the best algorithm for linear programming problem. But that's not a part of the syllabus. But understand that there's a method developed by an Indian mathematician, and it still holds good. And some researchers states that it is 50 times very good than simplex method. So first we will define what is simplex method, but if time permits, we can take a look at Karmarkar's algorithm or something like that. And then it's a transportation problem. As I told you, there are different methods called row minima method, column minima method, then least cost method, and northwest corner rule. And these are the methods to find the initial basic feasible solution. Whereas Ogle's approximation method and optimality, that's MODI. MODI doesn't means a name, it is the modified distribution method. So that's what it means by MODI method. And some people call this as a UV method, small u hyphen small v method, UV method as well. So we'll talk about that in a little later. So understand this are the different methods in transportation problem. And assignment problem, there's something called sequencing problem. Sequencing problem is the allocation of jobs to the machine. Assignment problem is assigning job to people. So one of the difference between an assignment problem and sequencing problems or sequencing model is that assignment problem should be a square problem, which means that there should be j work and k people. So it should be a square matrix, allocation of one job to one people. So that's what basically an assignment problem. Whereas sequencing model, we can have this kind of fun non-square, like n jobs and 2 machines, n job and 3 machines. Say if n is equal to 5, it is 5 jobs and 3 machines, and so on. And this case also, it could be n is equal to m also, but sometimes n can be greater than m, or sometimes n can be less than m also. So that's basically called redundancy. So we'll talk about that in a little later when we do the sequencing model. So, and module number 4 is all about a concept that is pretty much close to civil engineering. It's called project management. How do you manage a project? So there are 2 different methods. One is called critical path method. So the name suggests is critical path method, and the next is called a PERT, which is nothing but program evaluation and review technique. So these 2 things are pretty much and very important for civil engineering. In fact, I teach a course in civil engineering called construction project management or construction planning and management. So in that case, this is a core part of that course. And in fact, some of you would have done in civil engineering the course, and some of the civil engineering students are yet to do. So this thing will be pretty useful for that course also. And it's basically developing a network diagrams, and we'll find out the path that consumes larger duration. The path that consumes the larger duration is called critical path. The reason is that if you delay that particular path, any one activity in that particular path, the entire project got delayed. So that's why it is called a critical path. And in fact, another technical term associated with that is buffer. So the path does not have any buffer, zero buffer. Buffer is a free time, so you can relax it for a bit. But if a path does not have any, that path which does not have any buffer is called critical path. So we'll be discussing that in detail. But CPM is a deterministic method. The reason is that the time is deterministic. If I want to schedule an activity for 5 days, it is 5 days. No matter it is 4.5 or 5.5, it is 5 days. Bang on the target. But it is not practically viable. So many people have developed another method called probabilistic based method called program evaluation and review technique. So it's basically a usage of probability. It has 3 times. One is called optimistic time, and most likely time, and pessimistic time. Say you remember, if you see the 100-meter race in Olympic recently, if you see, almost all people are athletes. All people have got credentials in the 100-meter. But if you see the one, um, once one finishes first and then the second one, if you see the difference, there will be quite a few seconds, right? So that is basically the program evaluation review technique. So the objective of this problem is that initially we'll set some target that will be the most likely. Then optimistic will be lesser than the most likely. Say it sometimes like a world record or Olympic record, no? They finish it early. Or sometimes pessimistic, people who from your country, nominate for competing in the 100-meter, but then they couldn't do. They were, it's not because they are poor, but the people who ran in the first place and second place are very good than them. So it's most of a pessimistic time. So they took little extra time than the people who finished first or something. So those things we will be discussing in program evaluation and review technique. Then crashing a project. Sometimes if you want to finish a job early, you deploy more people. But when you deploy more people, the cost of the projects gets increased. Say if you want if you want to do a construction of a 1 meter high and sometimes like 25 feet length wall, say it requires 3 people and 3 days. But if you provide 6 people, you can finish it in 1.5 days. So but then if you provide 6 people, the budget gets increased for the payment for the people, or the wage for the people increases. But if it is something and a really really important thing that you should construct it very quickly, say if you construct a commercial building, the more time you spend in construction will be a waste, or it's a junk. So you reduce it so that your return on investment will be very high. Say for example, a mall gets constructed in 6 months by reinforcing a lot of people. Then it is a revenue that generates for the next 6 months. Whereas if you if you provide lesser people for constructing into 12 months, your budget might be less, but the return on investment will not be very high. It's as simple as that. So those kind of decisions we will be taking it in the crashing of project network, something like that. And module 5 is also a very important. It just sometimes like this might be useful in your regular day-to-day life also. How you manage your inventory. Say for example, you might use your data network data, or a, what do you call that, package, no? So data packages, how optimally you use so that you can attend all the lectures, unless you don't have an unlimited package. So if you have a limited package, you'll be scheduling, right? So we'll be focusing on this lectures alone. Or sometimes if you want to learn something in NPTEL or something like that, then you allocate packages and see to that you don't waste that, so that you'll optimally use that. So those things are called inventory. So holding stuff in an industry, and how do you make use of that. Or there's something called reordering. So when a stock gets over, you should be in a position to reorder. If you delay that, you have to wait a certain period of time and your business is idle. So those kind of decisions we'll be taking at the inventory control, something like that. And buffer stock, as I told you, buffer is a contingency. So instead of completely exhausting a component, you place an order. Some portion, when the when the inventory reaches the bottom line, you reorder at that point, so that when the component gets over, the the usage or the materials, the components arrives in, so that you can continuously use that without any break or something like that. So that's called buffer stock or something like that. And module 6 is queuing model. It's all about the waiting lines. This is pretty much useful for electronics, and people talk about the signals and systems when which say for example, um, during your examination, online examination, some people have a good bandwidth, they don't have any problem, and some people have a problem called latency. Their internet reacts very slowly despite they have a good processor, hardware processor, but then there's something called latency that prevents them. So those things are called queuing models. I mean, the waiting things and waiting lines or something like that. How far good in terms of developing a center or a service region, so that there won't be any queues or falling of queues or something like that. So this is a very good things in operational research. In fact, if you go to any railway station, even the counters, you see queues. In a bank, you see queues. Queues are omnipresent, so it's everywhere. So this methodology talks about how you can reduce by providing multi-servers, or even in a single servers. If the arrival rate is exponential, then you should really think of some mathematical way in which you can enhance your service time or something like that. So this is basically a very, very, very important module, and it has also has some implications with the simulations. In fact, simulation, it is QA model and the simulation. Simulation is entirely different stuff, but then they failed to do that. So it is more or like a queuing model and a simulation. So simulation is we will be using a lot of iterations and find out like best optimal solution. So we'll talk about that a little later when we do this in TR. And simulations are also applied to queuing problems, and that is what the final thing. And a very important method is called Monte Carlo simulation, or some people call Monte Carlo, so depending upon the pronunciation. Uh, this is pretty much important methodology developed in statistics, when which you make use of statistics to perform the simulations. So this is basically a very, very, very important thing, right? And in fact, many people who do quality analysis or quality control, they make use of Monte Carlo simulations. I mean, if you are planning to do your final project and that has got quality assurance or quality control aspects in it, then Monte Carlo simulation, what you learn in this module, is very, very important, and that will fetch you a lot of credentials in future. And module number 7 is a very, very important thing. It's my favorite also. It's called game theory. I hope most of you would have seen the movie called The Beautiful Mind. It's a movie based on the life of John Nash Jr., and who was pioneer in game theory. So game theory is actually a very interesting thing. It is all about strategy. It's in fact it's called strategical programming. The reason is that how it how you make a decision during games. I mean simulated games. It could be a games or it could be a business situation. So we model everything in a form of a game, and we'll see how you can make decision in your particular problem. So this could be very much interested. This will be very much interested for people who have own businesses. They can make use of this methodology in a greater detail. The next is called the replacement model. As I told you, as a mechanical engineer or a plant engineer or industrial engineer, you should know at when you have to replace an equipment, or if you want to sell an equipment, then you should look into the no, what do you call depreciation, and when you sell it, you have the optimum value. So that kind of decisions will make using during the replacement model, something like that. And as I told you, module 8 is the industry thing. So we will be focusing that in a little later point of time. And books. In fact, books are a little bit, very important for operational research. The reason is that if you have a hard form, then you can read it much better. But do not get carried away. The modern generation students, they prefer videos over textbooks or any books, reference books. So there are a lot of videos available. You can type in YouTube the NPTEL videos on operation research concept. Few important books, I mean videos or NPTEL course is like Dr. Srinivasan, who's the professor from IIT Madras Management Division, who have got a lot of videos on operation research, advanced operation research, and so on. And then another professor, Professor Deep, she also have NPTEL course. She also currently runs an NPTEL examination course. You can take a look at that. So she also have got quite a good lectures. So you can learn. So that's if you don't have any books, I provide books that are freeware. Maybe in a couple of days time, I'll send you a link so that you can start making use of that for your class or something like that. Right. So the one book which I studied during my college days is Hamdi Etaha. It's a wonderful book by Pearson. In fact, I studied in 7th edition, but now I think we have got 10th edition also. Uh, well, framing the syllabus, probably it is 9th edition. And it has a complementary CD, which a package called Tora. Tora is a computerized operation research solver. So we'll talk about that a little later. So this is a wonderful book to have. In addition to that, these are the Indian authors' book. But another very important book is J.K. Sharma, Operation Research. So that's a very Indian book, but it's a very good book. It's Trinity Publishers. It's a very good book if you want to buy or if you want to have or something like that. But absolutely not necessary. The module which we do, I do, will be comprehensive. So you don't need any textbooks. I'll give you a lot of references so you can make use of that or something.